I think we gave a quick intro about myself. Like, I don't want to go along with it at the interest of time. So we'll go through, I think this session is going to be a mix of theory, plus I'm going to have a lot of demos scanned up for you. It's going to be live demos. And then probably like we'll park the questions for the last 5-10 minutes so that like I can have the ground to cover stuff what I have to do today. All right? Great. So let me start right to the point, right? So at Snowflake, one of the guiding principles for building this AI, so what we call as Cortex, we'll see more about Cortex, which is our flagship Gen AI product, is that, so we want three things: make it easy for developers, make it efficient, and trusted. Obviously, like we had some session, like the last session I was talking about, there was a lot of questions around, okay, what's the trust, what is the data security, what other stuff we have, right? We took all these things in mind, and what I'm going to talk for next 1 hour is completely for enterprise, right? How do we do these things within an enterprise? Because that's where we need to have efficiency and trust more. Obviously, we need to have easy because we don't have skills ramped up amongst our developers to do stuff pretty quickly and easily, right? We want to get something running. So letting starting with guiding principles, like one of the guiding principles of making things easy is our whole unified platform. We have one unified platform that's going to cover you for Cortex AI, which is going to be our generative AI stuff. And then we have machine learning, which is called a Snowflake ML. And we have app development tools like your Studio, Notebook, Streamlit, and Copilot. We'll talk a few of them when I'm doing the demos. And then we have the model and governance. So I just want to call this data and model governance as a primary thing here, because everything in Snowflake has to pass through this layer, including Gen AI. It's not that Gen AI bypasses something and comes to you. Everything has to pass through this here. For example, if you're not doing AI, if you're doing normal data warehouse and other stuff, you have data inside Snowflake, and you have your access policies, access controls, masking policy, you name it, right? Whatever the control mechanisms that you have. So if you're having all those things, whatever rules that is applied, whatever policies that applies for them is exactly same thing that's going to be applied for Snowflake as well. So in Gen AI as well. So which means that Gen AI has to cross that layer before it can render the data to you. And we'll talk a little bit more about, I have an exclusive couple of slides where I talk about data governance and model and feature governance. We'll talk more about that, but I want to start with that note saying that everything has to pass through this one. Great. So how we make things easy? So we have a bunch of stacks, like the very thing that makes the whole platform super easy is our foundation models. So we have classified them into task and specific embed models. So what we mean by that is task specific, like I want to summarize, I want to complete, I want to do translations, I want to extract answers, sentiment analysis. You have all those task-specific stuff, right? We have all the functions readily available for you, which we call them as low-code functions. Because we wrapped all the logic that goes behind it within that function. I will just give you this function either as a Python API or a SQL function for you to go and execute stuff. And then we also have embed models, which we typically use in case of a RAG, retrieval augmented generation. We'll talk more detail about that down the lane, where I want to extract document content and then convert them into vectors for them to be used for semantic search. So in that case, like I use these embed models. We'll see about them a little more. And we have the foundation models, as you see on the top: Snowflake Cortex, A21 Labs, NVIDIA, Meta, Gemma. All these models are available for you out of the box. The good thing about that is you don't need to load all these models. The models are preloaded in a serverless ways. All you have to specify is that I need to use, for example, Gemma, or I need to use Llama, or I need to use Arctic. So just specify the model. Snowflake will load that for you and execute stuff whatever you're asking for it and get the response for you, which means that you don't have the infrastructure headache on top of your mind. Then that's another one which makes things easy for most of us, because we can concentrate on the business and seeing what we need to build. And second one is that all these things sit next to your data. You have to going to execute right within Snowflake's environment or security perimeter, what we call as, so that your data doesn't go out. I will talk more about that, as I said earlier, and you also don't use your data for training our models. The models are trained with a different data, and you don't use co-mingling as well. You don't ming customer data to kind of bring this stuff, right? That's the first step. The second one is everybody in the organization, irrespective of either he's a technical guy or a non-technical guy, he wants to interact with data. For example, business users want to talk to data in a natural English rather than going and writing SQL queries or doing something else. You want to build rich visualizations out of it. So all these people can use these two chat interfaces. One is Cortex Analyst, so which works with the structured data. And there is something called as Cortex Search, which will do a hybrid search, semantic plus keyword lookup. You will see more details about that. So which means that these two interfaces provides you with an option to kind of go interact with the data in natural language. I mean to say, just in plain English, I can ask questions and get answers from them. And then there's one more thing about it. Even if you want to go one more level up, I don't want to write any piece of code, and then I want to do something getting done. So we have zero code interface or no code interface called a Studio, which we call as AI ML Studio. We'll show that in the demo. That helps you to do stuff right away without even writing single point of code. I have a fine-tuning demo. I'll tell you how I make use of a smaller model to a specific task. I use a Studio to kind of train these models. And this whole Cortex AI platform, or which is kind of a groundwork that we did, is so stable and so secure that we built a couple of applications on top of it, which is one is called a Snowflake Copilot, which basically allows SQL developers and application developers to write query. The code generation of SQL stuff is done using that. And then we have one more stuff called as Document AI that allows you to extract content from the document, again using natural language questions, and it can help you to kind of play with the documents. Right? If you're a document company, processing company, you want to do a lot of document processing, we can use the same thing. For everything, there's an efficiency that drives the stuff. Right? It's not just that we build this model like that and start using multiple models. As a guiding principles, after making things easy, you also want to make things efficient. So what we mean by this, for that very specific reason, we launched what is called as an Arctic family of models. The Snowflake Arctic family is a kind of open source models that is even available in Hugging Face for you to use that stuff. In case what they make it more efficient is that we categorize them into 3 buckets. As you see on my screen, one is the LLM models, general purpose model that we use. The second one is Arctic Embed, more for token generation, the vector generation and other stuff, the embedding stuff. The last one is Arctic Tilt. Right, let me go over each of them and show you why we made it so efficient. For example, we call this LLM model as optimal use of experts of performance inference. What do you mean by that? So every model has an expert, right? Expert is a specific neural network component that does a specific task. For example, code generation, or I want to do a translation from a particular literature. I want to do science, right, for the biology or chemistry or other stuff, what you want to do. Basically, experts are used for that. The moment I call them as experts, it means that there is a heavy computational requirement that is required for us to kind of make these experts work, right? The GPU and CPU requirements that you have, which usually drives your cost up. Now, when I come to take all these things to enterprises, we're saying that all I'm talking right now is about the enterprise scenario where cost is a very important factor. I want to achieve the same performance, but at a lower cost, right? That's what we did with optimal use. What we made sure that with Arctic, we use an expert, but also at the same time, we continuously fine-tune your computation or the infrastructure that is required for this so that you achieve the same efficiency, no compromise on the output, but at a lower cost. That's the reason why you see the Arctic model sit on top of the best cost to performance ratio, because the amount of billions of tokens that you use to generate some response is going to be optimal compared to the same lesser infrastructure that you usually use with it. So this is one with Arctic LLM. Again, enterprise data, we just concentrated on a lot of people, like in the previous sessions I did, they'll ask me, okay, can I draw a flow chart out of Arctic LLM? You cannot do it because it's an instruct model, it's not a vision model, which means that I cannot generate any images out of it. I can always do with data because our goal was to make it work with enterprise data. The next one is obviously the Arctic embed model. Again, I want to call out the performance ratio here. It was trained at 1/4 of the size compared to the other model, but achieving the same performance what other bigger models or the best models in the industry give you. Again, this falls on the same Arctic embedding thing, kind of thing, which is Arctic family of models that we have. The last one is again even more. We trained Tilt to be 0.8B parameters to kind of extract doing document intelligence. In comparison to the other models, you also see this gives you the best, again, the performance ratio against number of parameters you train for, right? You're training smaller model, which is quicker to load, which means at the end of the day, number of things we charged for you is also less. Again, the models are bigger, the context window is more, where you'll be charged more. We'll see a little bit more about that. So it became efficient, easy, and then we drew the easiness was done because of the efficient models that we have. Apart from that, we have a list of foundation models that I showed earlier, like Reka, Flash, Gemma, Llama, and all other stuff, which you can use based on your context. The last one I want to call as guiding principle on this is, right, how do you make things trusted? The first thing sits on top of, you have seen my first block diagram which I showed you. The one that sits below is called as a Snowflake horizon, where we have all the security, governance, compliance, everything put inside one little product which you can use. And every LLM goes through that first horizon to kind of before it even touches the model, right, to get your response back. which means that all the access control policies, all the security mechanism that you have in place, everything is applied before I even go call the ones, right? The next one is model registry. So the moment I start to train a model, right, it's an iterative process. So I keep training the model V1, V2, like what you want to have for source code. I can use the model to securely store them within my own model registry, again, which is within the security parameter of Snowflake account that you have. I don't need to go out to store the model. Again, that adds to an extra layer of security. Third one is Cortex guard, which means that all the LLM functions that I'm going to talk or anything that you're going to invoke, it has a parameter that says guard equal to true, meaning to say like it guard all the harmful responses that I get out of my LLMs. Because LLM doesn't know which is harmful, which is not harmful. So it's under your control that you need to do whether I want to get a response back. You'll see an example of that at the end of the session. So all these three things make the whole stuff more trusted, meaning to say since I'm going to operate on an enterprise scale, I want these two things to be there first before even I can start showing the other fancy stuff that people usually have, showing, okay, my model can do all these X, Y, Z. All right? So next one, what we're going to talk about is, we saw all those blocks, we saw all those charts. We'll see like, what are the typical use cases that we technically apply LLMs or GenAI into, right? So this again, the common use cases which you have in mind, et cetera, et cetera. The very first thing I want to talk about is automated BI. So I usually call this as an ABCD of your artificial intelligence GenAI stuff, because I start with automated BI where I'm going to interact with the data in natural language. For example, Cortex analyst can talk to a structured data. So what I mean by structured data in here is that, so mostly like you have an enterprise data, you have a set of business users. Usually Cortex analyst is will be used by business users to kind of talk to this, right? They understand domain, they understand semantic model. So what we basically do is, like as a developer, we kind of interact with the business users, allowing them to kind of give us the semantic model, how we want to generate what table, what are the synonyms for this particular field, how do I query this, what description I can have, some examples of this data. So we get all these data in, and then we feed that in for Cortex AI, which is a REST API, which means that it can also interact with Cortex AI from your application as well. In case if you have an application, I want to query the application, get data back, I can use Cortex API to kind of call this function and get the response back and show it in your own interface. It's not necessary that I have to be sitting inside Snowflake. So I'll show an example, how do we do it within Snowflake. So that's structured data, we need a semantic model. And the recommendation is that don't have one huge model for the entire organization, right? So it depends on the use case, keep the model small. As of now, we have to handcraft it. But down the lane, we also probably might introduce a no-code interface where you can also generate this semantic model right within a Snow site, which is our Snowflake's UI, all right? Great, so why we say this here, because we proudly say this, Cortex Analyst gives you 90% accuracy of generating SQL. So this is what we say, because we know text to SQL is hard. Again, text to SQL as enterprise is hard. What we also did is that with Cortex Analyst sophisticated agent AI, since we have a lot of foundation models that we already have, which is preloaded inside Snowflake for you within your account. So we just take the responses out of all these individual models, compare them, and find out the best SQL that it generates and give it to you. So that's the reason why you are able to achieve that 90% accuracy. If you see this last one on my screen right here, so we're kind of generating Meta plus Mistral plus Snowflake Arctic. We generated the response out of these three models and then gave you the best SQL that is generated out of it and gave it to you, right? And it just makes your life much easier because you have a combination of other stuff. Again, this is driven by the semantic model. So you have to define your semantic model perfectly, which means that, again, it's a combination of business plus developer. Developer is just to connect it, but the business need to generate it because end of the day, this is going to be interacted by business, right? Now, we have two interfaces. Snowflake Copilot, which is an application which is built on Cortex AI. Again, it also uses generation, SQL generation. We also have Cortex Analyst, but these two have two different use cases when we kind of take them up. For example, Snowflake Copilot is basically used by data analysts and SQL developers because I want to generate SQL right within Snowflake, whereas Cortex Analyst is used by business users. There are two different personas who basically do this, okay? And then if you see the precision, again, the precision of Snowflake Copilot, because it's used by app developers and SQL guys, which means that they can go back and tune it because they are technically profound to kind of do this job. Whereas analyst needs to have high accuracy because it's going to be used by business users, right? They don't have idea how to kind of go back and tune your SQL and other stuff. So depending upon your context, where you're going to use, you can use these Copilot as analysts. End of the day, the principles are same. They use the same foundation models, they use the same LLM functions right under this to go and deliver stuff for you, all right? Let's kind of go view that with a demo. Probably that will make things more interesting for you. I'm going to shift back. And so my data is probably, I'll just share you what data I'm going to use. So I'm having a data with support tickets. So this is a very common scenario because I'll be able to explain all the stuff that we do here. So I have a support tickets here, so which is kind of spelling up like for a telco company, a fictitious telco company, so where they are sending it across cellular, business internet, and customers call up and send you a request through contact preference and other mode. So this is what I have. What you see right now is Snowflake Notebook. The advantage of Snowflake, it's similar to your Jupyter Notebook, but only thing what you do is like this executes right within your Snowflake environment, close to your data. So this is just secured at the end of the day. It also allows you, rather than Python and Markdown, it also allows you to execute SQL functions, right? If you can directly execute the SQLs right within your Snowflake notebooks, right? So what does Cortex Analyst do? So in this case, as I said earlier, so I have a domain model, that's got created. For example, I told I'm dealing with support tickets, and I gave some description, told the database where this data is in, the schema, and the table from where it has to do this. So this is the only use case that I'm going to talk to you about right now. And give what is called as the dimensions, are nothing but the attributes that I'm going to extract out of this particular table, right? The data that I'm going to give it back to my model to extract. I'm saying ticket ID, then I give some synonyms for it, like ticket ID, ticket number, what all the ways you technically call within your own domain context. And description and the expression, right? I've just kind of give some samples as well. So this data is usually, you can build this data with a developer sitting beside a business user because he knows all these things that needs to be generated and give it to you, right? Once I have this business model ready, so let me go to my page. So what I basically do is like I load this model, and what you're seeing right now is Streamlit-based interface. So what is Streamlit? Is like Streamlit again is a very easy to use Python-based widget language I called as, where you can create beautiful visualizations. It's an open source project. Snowflake acquired Streamlit a couple of years ago, and then Streamlit is now bought into Snowsight, what we call the UI that you see right now. I can build rich visualizing applications using Streamlit right within Snowflake, data sitting next to this thing, right? I loaded this thing, particular stuff here, and then I have this API call. As I said earlier, Cortex Analysis REST API. I'm going to give a call right from within my application. So again, a Python-based application that you're seeing here, but you can give it from any application you want. I'm passing this file, the semantic file to this, as you see here, and then I'm going to give a call for this, all right? So the very first question probably, I'm just going to say like, let's say I want a breakdown of customer support tickets by cellular and business internet. That's service type that you see here, right? Let me go and execute this call. Assume that you are a business user. I gave this application to my business user. The business user right now is going and executing this stuff, right, sitting within Snowflake. And there you go. I got a response back saying how many service type tickets on cellular, 114. Business internet is 35. It also generated the visualization for you, which is usually done by developers, because right now I'm a business user who is using this. And also, it generated you a SQL query that I can use it. For example, I'm a business user, I'm doing this analysis. Right now, I take this query, give it to my developer team, and then say, hey, can you optimize it and find out other insights that I want from my data, right? It gives you all these stuff again. So let's ask another question probably, just to make things a little interesting. I want to ask how many unique customers have raised a support ticket, service type cellular, having email as a contact preference. Again, it's going to follow the same thing here right now, and it's going to get back the same result saying how many customers I have who are using email as a contact preference and then cellular as a service type. So if you see this one, right now I'm interacting with this in natural English. There is no technical terms involved here. It's natural English that the business user is doing. I have the interface neatly. All these chat interface is doable in fraction of seconds and minutes using Streamlit. It's all there. The widgets are available for you. All I have to do is put the widgets into your Python code and start calling it. All right? So that's with Cortex Analyst. Let's go further. So that's one of the business use cases that you usually have. The next one is like, I want to build conversation assistants. Right? This is again a very common use case that we see right now, because every site you go right now is having a virtual assistant sitting there, may I help you, and then you have a lot of conversation happening within that, right? But if you remember for a second, there is a thing, right? Because LLMs are trained for a particular period in time, right? And particular general purpose stuff, which means that, let's say I'm taking my own use case, which I called right now, for a customer support tickets for a telco company. It doesn't understand the telco domain knowledge, right? It doesn't have those terms. It doesn't understand those terms. So I have to inject those terms for it to make answers those questions so that it knows how to answer your stuff, right? For example, assume a customer support guy is sitting on a phone and one of his customers is coming and asking me, hey, how do I do this stuff? Why my bill is high? So what do I do this, right? He has to go dig information from lots and lots of internal document knowledge bases and other stuff from where you have to find the information and answer him, right? Which means that he'll be hanging on the phone for long. Again, that's again a recipe of frustration, right? He doesn't like to be, none of us like to be on this IVRs, listening to this. We want our query to be resolved. That's where document search comes in, where I want to make my LLMs, the large language models, understand my domain and answer my questions based on my domain, not on the general thing. So that's where documents and Cortex search comes into picture. So it uses a technique called as RAG, so which is called as retrieval augmented generation. So what we do on RAG is that first assume that I have a copy of data ingested. So we have Snowpipe streaming, which means that I can also inject streaming data. It's not necessary that I have to have all these documents. Then what we do, once the documents lands on a stage or a table, we use Snowpark Python, which is the Python APIs that we have within Snowflake, which you can use to extract these UDFs, to extract and the chunks, which means that extraction of each individual text or line from your document, and then embed and build. If you remember, one of the foundation models was task-specific and embedding models, which means that it can convert these text into vectors, right? So which is like nothing but an n-dimensional floating point array, which you basically store. Since Snowflake already has a database and database concepts inside, you don't need a separate what you call as a vector DB for it to be allowed. We have a vector column data type where you can store the entire data within Snowflake, which means that you don't, one of the other integrating system is out of your thing, right? We have one platform, we can do everything, right? We bought that in, and then probably what we do is like we just dump all these chunks as vectors within a table, and then whenever the question is asked, basically the question also gets converted into vector, and there will be a semantic search that will be done on a vector space, matching your chunking document. All the relevant documents will be fetched, and then they'll be dumped into your prompt or your context for the LLM, and then we query the data within that context. The moment it has those relevant chunks within the prompt, it will be able to understand how to basically answer that question. So that is what we do with RAG. We basically retrieve the chunks or documents, dump it within your prompt, and then give the question, ask the question in that context. It will be able to answer specific to a domain. Okay? Let me repeat the whole flow. Basically, we take the documents. Let's assume that we have a stage where we have all the documents imported, or we keep importing it. We have a specific Python UDF function, which basically extract, let's say, assume PDF. It extracts the PDF out of it, and then kinds of ask the question and store them inside your database as a vector columns. Once this columns is stored, the data is stored within them, what we basically do is like we kind of ask the question. Once the question is asked using the chat interface or whatever the conversational chatbot that you're building, it kind of combines these two data and kind of answers the question based on that context. So that's where RAG is very useful. So this is one level, right? In Snowflake, we went to another level in Cortex search. What we also did, what we call is a fully managed index and retrieval using hybrid search. What I mean by this, we did RAG. You know how RAG retrieves the document right now. We also do a typical lexical keyword lookup, right? The normal lookup that we do. Fetch all the relevant documents and then rank them, fusion and rank them in a particular order, and give you those set of K results for you, right? Whatever the K results you're asking for. In this case, it becomes more effective because we are combining two powerful search mechanisms of semantic search plus keyword search. So that is something which we do in Snowflake, and it's all done within Snowflake in fraction of seconds. You don't even notice how fast is that, and then give you the data, right? So let's see an example how this works, right? So I want to show you an example of a chatbot. Let me see if my chatbot is up. Let me start this. So I loaded a bunch of documents here. So some of the invoices that I load here on my page right here. And then let me open a document and show you a document where I'm going to do the query on. So I assume this is a document that I have. It's again an invoice from a telecom communication company by a customer named Gregory Anderson. And then he's asking about a question around this fees, international roaming fee, which is $85. I'm not sure it's very clear there. It's clear there, the back? Okay. So I'm going to ask a question about this invoice. So assume that I'm on a chatbot. I think again this is built, this RAG application again built with Streamlit. So Streamlit has naturally the chat widgets available out of the box. I can just use them and connect them with the data. All I have to give them is a Snowflake data frame, right? Pandas data frame, end of the day. So I think I uploaded all these documents which are converted and stored as vectors. Let's assume that I ask a question like say, I just made the question keycut shortcuts to avoid typing. What kind of service does Gregory have? So if we all go right, like I should get cellular service line 2 plan. This is the answer that should get back. Let's see if I'm able to get that. So there we go. In fraction of seconds, not even less than a second, he was able to answer the question from the document. And then I'm going to ask another question. Was he charged international roaming fee? It's going to go back and search in my documents and come back and say, hey, you have been charged an $85 international roaming fee. Again, these data come right from my documentation where I have this. Right? Let's also try to see which, I'm going to ask another question which is not here. Which invoice details about this? I'm going to see if it's going to get the, I should get 9987. Let me see if I'm able to get that with a little more chunk onto it. So let me see if it's able to answer the question. Yeah, there we go. It says a little bit more information added to this with total balance and everything, but it was saying that invoice 9987, since it's a demo, like I can fine tune this response output as well. So this is what it does. It gives you this invoice number as well. So this is so fast that I can keep kind of converting the documents into chunks, put that inside the prompt. We'll see more about the prompt in a second, and kind of start casting this using Cortex Search, which will make, like, you can make your support guys really efficient and support. Like, I think probably I have a question probably.
Yeah, what are the different document types it can take?
I think as of now, whatever I experimented with, I can do images, I can do PDFs, I can do docs, docx, and all this stuff. Yeah.
PDF and what are the other documents?
The docx, the Word docs that you can use. I think I've not experimented with images. I just started to experiment with images to see it can also extract the image as well.
Okay, and the other thing you talked about was streaming data. From IoT devices, it can be just like that?
Yes. I think we have a concept called as dynamic tables, from which I can directly take the streaming data, whichever format I have, and then I can put it inside the dynamic table where I do the typical extraction. Let's say, for example, it's coming as a JSON. I can do a JSON extraction of the data and dump it into a table. Welcome. Great. So, so we saw about conversational assistants. Now I'm going to go a little bit deeper to the last level, because all those things right now we are seeing is everything is based on the foundation models. What models we have, what models we support, and we have fundamental functions. Yeah. Yes. No, that does a keyword search and a semantic search. So the synonyms comes only when you're doing Cortex Analyst. Right. So let me go further. So all these things, what are the applications that you've seen so far, Cortex Analyst, Cortex Search, are backed by a low-code functions, or what we call as an LLM functions, that we already have available out of the box. Right. You don't need to write any code for this. We'll see an example of that. That uses the foundation model to start querying the data, right, doing sentiment analysis and other stuff. Okay. And also the document AI. This is a typical structure. How do we call a function? We have a Snowflake Cortex complete function that does a completion, or a what we call as, and then we use the first parameter, we use a foundation model, Snowflake Arctic. We'll see a few other models that is available. Then you basically give it a prompt. I'm kind of combining SQL and other stuff here, right here. And finally, I can query it on a table. So right now I'm applying LLM on top of my enterprise data. I have all these models available for me to do the query and talk to this, so you don't need to worry about how do I actually, what is done underneath it, how do you convert this data, etc., etc. Okay? And also it has SQL, Python, and REST API. It depends upon whichever thing you're familiar with or expertise with, so you can just choose which of the programming language that you want to run this function against. So all these functions which I'm going to show in next 5 minutes or so, everything has a Python and REST equivalent. Meaning to say, like, I can also integrate that with an existing application if you want. All right? Great. So, and also, like, it gives you adaptability. Like, you can also go to another level. So right now, if you see, these are the list of foundation models that I have on the second box that you see on my screen. But you might be wondering, okay, I want to train my own model. Let's say I want to train my model and bring everything together, which is most advanced use cases. Then you can use what is called a Snowpark Container Services. So where you can bring in an own model. We give you all the infrastructure that is required, a CPU, GPU infrastructure to kind of do this stuff. You can train a model and deploy a model and make it available for use cases as well. And we also provide interfaces to external APIs, like, for example, you want to do OpenAI or Azure or Gemini. So if you want to call those functions as well, through APIs, we have a connection to those APIs as well. All right? Great. So let's go see a few examples of how do we use LLM models. I'm going to go here, go back to my browser window, sorry, and then go to LLM functions. So I'm just importing a couple of packages again on Notebook. So we already saw that I have a support ticket, the very first thing I want to talk to you about is classifying text, right? So what I did is like I have a bunch of service types in my support ticket, cellular, business internet, and then I have an home internet, something like that. So what I given is like I'm just going to use classified text function, which is available out of the box. For stratified text, I'm just saying that, okay, classify all the service types into either internet or phone, right? Again, this is a very demo-ish thing, but usually we use for these things. And I'm going to kind of doing a labeling here, like with this particular support ticket, whether it's an internet support ticket or a phone-based support ticket. I'm kind of calling this function here. I think I'm calling snowflake.cortex or classified text. I follow the text from my support tickets table. Request I'm renaming it as text, and then array construct as classes. These are the two parameters that it takes, and out of the box it gives you a JSON with a label and a score. I'm using a label here to kind of do this stuff. So all the functions within Snowflake, right, all these functions that I'm going to talk right now, everything returns you a JSON response, and the JSON response has a score in it, the score from 0 to 1, which gives you the more higher the score, the more accurate the response is, so that whenever you are building application with Snowflake and then kind of calling these functions out, you can extract the JSON data and kind of see what is the score there and find out whether this is a better score or better accurate based on your application needs. Every function has JSON response. I'll show you an example down the lane. The next one, what I'm going to do, this is what I was saying. So these are the models that is currently, as of now, I think I prepared this demo like a couple of weeks ago. So these are the models currently supported. If you go to the official website, talks.snowflake.com, I will see what all the other models that we are keeping adding the other models to it. So these models are right now supported. For example, I'm using Arctic here and then calling complete. What I'm basically doing here, summarize this request in bullet points. This is what my prompt is. This is usually called as a prompt. I'm putting my prompt here from support tickets as issue summary. That's what I'm doing. Again, these are the tables that sit within my thing. I'm just limiting to one so that like it's easy for us to visualize the data. And then the good thing about Snowflake notebooks is that I can also extract the data, the output from the previous SQL cell into a data frame. And then I'm converting that into pandas. There are two data frames. One is called as Snowflake data frames, which are lazy load. End of the day, if you see behind the Snowflake data frames, they are all SQL, right? And then if I'm using the other normal pandas data frame, we also have Snowflake pandas GA a couple of weeks ago. You can also use that as well, where I can use the pandas paradigm to kind of go query the data, right? So this is, imagine like Snowflake, Snowpark data frames. It's quite similar to your kind of thing when you want to move from Spark to kind of to Snowflake, right? It makes your things much easier in that way. So I'm using Streamlit here to kind of write this text. I'm just extracting this stuff. So this is what you see here. I'm kind of doing, okay, this is the text that I have here. I travel to this, and then the complete function gave me as bullets, because that was something which I was asking my complete function to do. Because I'm asking it to summarize this request as bullets, right? Whichever come within this request. Okay. Now I can also do a sentiment analysis. I'm going to take all my requests, like 10 support tickets, and find out what is the sentiment behind it, what is the customer sentiment behind it. So usually the sentiment gives you a score between -1 to +1, -1 being negative, +1 being positive, and then you can go like floor or ceiling between them, right? For example, I have 10 tickets where I have a neutral sentiment with 0, negative sentiment with -1, again +1 is a positive sentiment. Again, I try to use Streamlit to kind of do a little bit of beautification with the output, calling it with all the smileys and other stuff that you technically see with the request. Right? I can do a sentiment analysis, again using the Snowflake Cortex.sentiment function, LLM function, right? Great. Next one, which is the most commonly used thing, where we want to summarize a large text. Right? Let's say we have 100 lines of text, we want to summarize, let's say, for 200 words or 300 words kind of stuff. That's the usual request that we use LLMs for. I can use Snowflake Cortex.summarize function to basically see this. For example, this one is like 5 lines of code. With the summary, I got it like to 3 lines, right? Even smaller than that if I could give more specific context to it. So everything is defined. So you'll be wondering like how these things work. Behind the scenes, everything is converted into an LLM prompt for you. So that's again a boilerplate code. Like I take this prompt, put it inside the prompt, all your requests and data and context, and go query it, right? That is how you use. If you remember RAG, is exactly the same principle that is applied here as well behind the scenes. I take the data, I use your prompt, combine everything together and give us a prompt. Prompt is nothing but a guidance to your LLM what you want to do, the LLM you ask it to do. So let me see if I have a slide for that. If I have time, I can show you how the prompt totally looks. We usually call them as prompt engineering, where you basically kind of do all these prompt like priming, style, tone, error handling, how the response to do, etc., etc. So in this case, I'm kind of defining a prompt saying summarize this request in less than 200 words, and I want it to extract fees, request, and country in a JSON format. So we are telling what it has to do, how many words it needs to extract. I also want to extract the fields out of my JSON response. You can do it with CSV or you can do it with anything else. And I'm going to use Snowflake's Cortex.complete. I can also change the other, the listed LLM models that we have, like Gemma or Llama or anything here to kind of do this one. And then I'm kind of giving an instruction, again, running the query on top of my support tickets table, right? Again, the enterprise data comes into picture. So when I do this one, so it's going to execute this query, extract the thing. I'm just going to do one. So, and then I'm kind of plotting it again, just for more clarity thing. So it gave me back a response, the same response which you got here, the JSON ones that you see here. I kind of plotted this here. Fees, $90. Request is what the request I have. The country is Japan. So that's exactly what I asked it to do. Put fees, request, and country in JSON format. So again, ideally, for all these cases, you'll be writing lines and lines of boilerplate code, because after the first time, every time you write, it's going to be a boilerplate code, right? Because you're going to have the same logic, only my data is going to change. What you have done with Snowflake, we have given you all these low-code functions, which means that you don't need to code. You can use combination of these functions to achieve your tasks. These are what we call as task-specific models, which is used behind the scenes. I can also use translate. We don't have all the codes available for translate. These are the only languages that is currently supported here. I just did the same translate like text and then to from language to language, like I just translated that into French. And that's what you see here. Right? This particular text has been translated into French for you. Okay? And only we have a limited set of languages that we support right now. And also, I can also extract an answer from a specific text. This is again a very interesting stuff. Let's imagine this, say you contain the same text, for example, and I want to extract how much fees I was charged, the international fees I was charged here, right, the $90 stuff. I'm going to do the same stuff for multiple 3 different rows on the support tickets table. I'm using the same LLM function, extract answer, how much roaming fees were charged, and then I'm kind of going to go on the support tickets table. It's going to go there and do a natural language question on the table text and the record text that is there, the request type. I'm going to extract and show you the answers. Let's say, if I got to go back here, so let me see if I can, let me go down a little. I can give you a little, I can also extract the request to show you like what is the thing right there, so that you know what is that, right? Okay, so you have these things here. So you should have somewhere, I have $90 here, I should have something $90 here again, and then $85 here again. So I was asking for roaming fees for all these 3 things. It's going and asking how much roaming fee was charged. It's going to go to the request text that the customer has raised and kind of extract the data using a natural language query on it. Okay? Great, awesome. So we have all these things, and also I'm going to talk a little bit about document AI. Before I go there, I want to show you that this is the no code interface that we have right now. I have create custom LLM. I have a fine-tuning demo. I think I have enough time to show you that as well. I can create a Cortex search service, which means that right now I'm doing a search. If you remember that I use a RAG search on set of documents, I can also write it as a SQL function and expose the function as a REST API. Right? Yes, please.
On the RAG thing, we have the document which can be ingested. We have the streaming which can be done as well.
Right.
So do we also have the databases which can be, for example, some enterprise databases, EBS or whatever, ERP system, and they want to do that enterprise data, search on the enterprise data. So do we have that? That can be.
I think for this, the data, when I do all these search executions, the search execution basically runs within the Snowflake's security perimeter. If you have an external system, then you should have some mechanism of bringing the data into Snowflake and then start querying it.
So it's like 2 terabytes of data.
Yeah, I understand that. I think for that, like, I think we can, then you have to start to use the REST APIs. Right now, whatever I show you, it was right now executing within Snowflake. So we have also the REST API equivalent for this. Cortex search service is something which we can use to kind of do this stuff. Define your search service, spanning multiple different systems where you have thing, and then kind of query the data and run the data on top of this. So we can send the data back to search service to kind of query the data and get the response back.
So the data is not leaving the original premise?
No, it will not leave. So even in this case, the data doesn't leave outside Snowflake. So every data is right within Snowflake. It's not even charged with the LLM, shared with the LLM providers. Let's say, for example, Llama, if I'm using Llama, which is OpenAI, right, so or Meta's one, if I'm using that model, when I query my data still resides within Snowflake. Snowflake doesn't share the data with Llama for any of those cases. For any of the models you use, your data is within yourself. That's strict governance that you are putting across. For your case, it's more Cortex service, and again, the volume of data does really matter because every LLM model has a context window, right? How much data it can take. The biggest model, the Llama 3.145405 billion parameters one, that takes maximum of 128,000 character count. More than that, it cannot take. That's a prompt size. So everything is depending on the prompt size. If you go beyond the prompt size, either you get a 404 error saying I cannot process your request, or you have to reduce your prompt to something smaller. So again, so for answer your question directly, it's doable. Little complex because you have to connect multiple different systems, but you have to define a Cortex search service to kind of basically do this. And again, like once the data leaves the Snowflake perimeter, which means that it's out of my Snowflake's control, then you have to be responsible for how do you handle the data. So because once it comes back again into Snowflake, we'll take care of it. But once it leaves outside Snowflake, then again, you need to be responsible how do you actually control the data, right? The governance policies that you have on them.
On another note, maybe you are going to be covering that. How is the cost part for Cortex? Is this like character-wise or?
It's based on tokens. It's dollars per million tokens. Yeah, that's how it is. Okay. Let's go further. So this is the low-code interface that I have. We talked about the Cortex search service. The gentleman was asking about how do we integrate these things. Everything has an API behind the scenes, which means that I can use API or can I just use this? Because for example, if I want to create a forecasting ML function on the data, just click this and few clicks, you should have the forecasting model ready. Maybe it will take some time for the model to be built. You can start querying it. The very interesting I want to show you about this here is document AI. So just let me select my warehouse that I'm going to use for this. In Snowflake term, warehouse is a compute where your query is executed. It's not the actual data warehouse where your data is stored. The Snowflake architecture splits your compute and your storage separately so that both of them can scale. That's the coherent of the architecture. So whenever you read about warehouse in Snowflake, imagine that that's a compute that's going to be spun by Snowflake on the respective cloud providers. Okay. I have an invoice info. It's the same document that I showed you earlier, but I had a bunch of documents. I want to extract data like my invoice number, the due date, the balance, the PO number, the customer details, and the international roaming fee out of it. So what I need to do is I need to kind of give this document a bunch of documents. The more the documents you give, the more the performance and accuracy here. So since for this demo, I just had 4 documents. Whenever I upload a document to document AI, it reads through the document and then I can ask natural language questions against the document. For example, I'm asking it what is the invoice number. So it might return 3943 sometimes, but sometimes it will not return you the correct answer. So basically you have to correct the answer and give it from the document so that I can say, okay, this model invoice number is like 3943. So that's where it will start to show you the accuracy as 1.0. So what are all the extraction that I need to do? I'm doing a PO number extraction. I'm asking what's a PO number, invoice due date, etc., and all these stuff. I kind of extract all the necessary information from this document. The maximum size is 50 MB. I cannot upload more than 50 MB of document for this to do this. Once I do this model, these are the ones which I call as values, and then I attach a variable here. Technically, imagine a variable like your column names, right, on the documents. When I do a query on a table, I get column names. I have to call that particular thing. Imagine like a column name, but it will be written in a JSON format. I do a build, values to extract. These are the values I extracted from this, and then usually I can publish a version of this document model. Here I'm published a version called as build version 1, and that's exactly what I use as part of the query. This gives you a query sample. How do I kind of get? What you basically do here is that you specify a stage. A stage is nothing but a place where we store documents within Snowflake, right? So this could also be like, it could be an S3 bucket, or it could be AWS blob store. Anything could be there. We can connect those stores, and here we call them a stage, and then it doesn't copy the documents, it just links those documents like a window for you. And I can refer the document using a specific syntax, and then kind of use and read the document. I'll show you how do you actually do that. So this advantage of version, because like I can keep iterating my model, keep improving my model, so which means that if I get a new version, new model, I can just specify that particular version. Either I can do it single document, I can do multiple documents, either way you want to do. Okay. So let's go back and to my the same LLM function where I have as document AI. In this case, what I'm doing is that I'm using that invoice info model that I created earlier. I'm using a predict here, get pre-signed URL documents. The docs is a stage where I have stored all my documents, the PDFs. I'm calling this invoice 9987 PDF. This is the PDF that I'm asking it to kind of extract the details from. So which means that I get the invoice number, balance and every other stuff. And then I just execute this. So this is going to return me a JSON response, extracting the document details. Let me also get the document. I'll also show you the score also in a second. So how many minutes? I have 15 minutes left. Okay. So this takes a few seconds for this to execute. Let's give some time. If my warehouse is down, it brings up my warehouse and kinds of runs this. So what it basically does, it gives you a response like what you see here. Let me see if the response has come. Okay. All right. Don't worry about that. So this is a plotting I did again. This is using Streamlit. I kind of extracted the invoice number, PO number, and everything from the previous cell thing. And then I kind of say what is the international roaming. I said this is a total number. I can do some kind of a delta. This is technically not a delta, but I want to demonstrate the other nice things that we can do with Streamlit, which also gives you the delta, right? Sometimes the higher the weather, lower the weather, you want to show all those things typically when you're kind of doing sales forecast, right? When the sales forecast went up last 6 months, came down last 6 months kind of stuff. So it gives you this JSON document. Let me copy this JSON document and I'll show you how it looks like. Okay. So this is how it looks like. So each value that I extracted, it comes back with a score. As I said here, if you have multiple scores, multiple different numbers for the same one, right? It gives an array because I could have different customer name and address in the same document. There's a possibility that I can have something like that. It gives you all these things and you can use this score to kind of basically find out which is the best score for this particular customer name thing, right? Which is a mapping again, end of the day. So which is going to give you this particular value, is name and address of the customer. So everything has this, and finally, it also gives you the metadata OCR score, how my OCR is able to read this whole document. What is the accuracy level of my OCR that's running behind my document intelligence, which is powered by Snowflake Arctic Tilt model again. So again, it's document model that's powered behind the scenes, right? So I got this one, I just plotted this one, did a little math around it, get the best ones out of it, and then I use Streamlit just to want to demonstrate how versatile Streamlit is to do a lot of other tasks. I just use few widgets here. There are lots and lots of widgets available in Streamlit which can do this stuff for you, right? Great. So this is document AI and LLM functions which you saw right now, and then I also want to do some amount of fine tuning. So what we do with fine tuning, okay? So why do we use fine tuning? I'll tell why do we use that. Okay, we have large language models, right? As I said, each model, the large language model takes a bigger context window. So when I'm running this against an enterprise data, in typical production scenarios, I will have hundreds, thousands, millions and billions of rows that I need to query on, which means that my cost to call those functions against those APIs is going to increase, which means my cost to use LLMs will increase because the larger general purpose models are trained for more general purpose, so I have to give more context and more data to it, which means that it's going to increase my cost. So in those cases, what we do is what is called as a fine tuning. In fine tuning, what we do is like we take a smaller model, for example, Mistral 7B, and kind of take this model and train it for a very specific task. And then use that thing for kind of doing your work, which means that it brings down your cost like 1/10, because the smaller models has a smaller context window, which means that when I want to train it, I'll train it with what data I want it to be trained, and then query it based on the data. I'll show you an example of how do we actually do this. Okay, we go here. So this is the thing I'll show you in the code, so don't worry about this slide. So let's go back to my fine-tuning demo. So this is what I have. Let me start my warehouse. I have this data, so which means that I'm kind of doing the same customer support ticket. So one of the need for me is to kind of go and categorize this whole support tickets into cellular or whatever the types that my business has defined. For example, my business came back and say, okay, categorize all those tickets across roaming fees, low data speed, lost phone, add new line, and closing account. This is what I call as a prompt. Prompt is basically guiding the LLM to extract the data that I want. I make the LLM say, hey, you are becoming an agent, a customer support agent or somebody. impersonate yourself as that, and then use these categories only, don't use any other categories that is defined on my table. Finally, return my request and other stuff, right? For example, if you see Arctic was the ones I used in LLM functions demo. In this case, I'm using Llama 3.405B model. This is the best open source model right now available, and it's the biggest one that you can have. Okay, I'm kind of giving the request, following the prompt. If you remember, we had seen Cortex complete function. I'm using the exact same function to kind of get this data done. Okay, I've not executed this, sorry. All right, so let me execute this, and then now come back and execute this. And this should take like 5 seconds or something to get me back a response where it categorizes all my support tickets based on this particular one. I think it's taking a little bit more time for this me today. Okay, let's wait for that. Okay, so it goes and categorizes these tickets based on whatever I said to here on roaming fees, low data speed, lost phone, etc., etc. And there you go. I categorize. Usually, what we do is like to do such kind of a categorization, we write business rules or use business rule engine, go kind of read your data, extract the information, and do this stuff, right? When the data is changing, right, this becomes hard for you because like if I introduce new service type or if there's going to be a different one, it's going to take more time and more effort. So with LLMs, I was able to do it quickly. As I said earlier, this is a very expensive LLM because the model is large, which means that its cost is going to shoot high. So what I tried to do was, I was trying to use Mistral 7B, which is a small LLM. So if you go to our docs, it will tell you the exact number of tokens, what we call as, how much these LLMs will take. Okay, that will give you an idea of what should be your cost. The higher the number of tokens, the higher the cost. The lower the number of tokens, the lower the cost. Mistral 7B is one of the smaller models we support. I'm running the same prompt against it, and then what I'm doing is, I'm kind of classifying this, like having the response with large response as well to see how it performs, right? Ideally, the smaller models will not be as accurate as the larger models. It will be, the response will be kind of pretty close or okay or kind of stuff. Let's see what happens to this. So while it does this, like, okay. It's taking more time. How much time? It took 17 seconds. It also takes more time. So what we also do, like while it does, so once we have this response done, right, what we basically do is like we create a data set, a couple of data sets here, a training and evaluation data set. For training data set, we use the prompt, which you already know, ticket ID, which is what I want, a prompt, and a large LLM response that we got earlier. Because when we do fine tuning, I train the smaller model with the examples from a larger model or other stuff. That's how I usually do a fine tuning stuff. Okay, this is what I do here, and then kind of build these two things. And then I think it got response here, I guess. Yeah, it got a response back. You see the larger response model, it accurately say roaming fees, whereas the smaller model just, it was kind of, it's okay, but it's giving more other details as well, which is not required in this case. So that's exactly what we did in this case, kind of taking those outputs, this large response model output, ticket ID and everything. We are creating a couple of data sets, a training and evaluation data sets, and then kind of do this stuff again. And after this, to tune the model is going to be a piece of cake. What we basically do is like, let me go back to here, and I go to the studio, and there is a create custom LLM thing. I'm just going to click on this. I'm going to say I'm going to train a Mistral 7B model. I have the warehouse and other stuff set. It's going to be my database where the data is there, and choose the schema, the data schema where it's going to be there. I'm going to say Cypher demo, and now some name what you want to give. Okay, it's going to check for the name. Now it asks you for the training data set. If you remember, like we created the training data set here, the support tickets, and then stored it in a table. It uses Snowpark Python to kind of take the data frame, write it to a table. So which you can do it right away there. So it's kind of doing that stuff there. So I'm just going to go there, choose the training model, and next it will ask you which is a prompt column in that model. I'm just going to select the prompt column, and then which is the output that I need to get from the fine-tuned model. That's a large response model which you have to do. Give me 1 second, I'll just finish this and get back to your question. And then we just take the other one, and then finally we also give the inference where I have to run my training on this. I give the inference model, and next, that's it. When I click start training, you should start training your smaller model. No infrastructure from your side. You're not going to worry about what infrastructure, what GPU, what CPU, what other stuff you want to go. Snowflake will take care of it. Obviously, there is a cost associated with it. So what I also did is like, I just, for the interest of time, I already created this model called a support tickets fine-tuned Mistral 7B. Now what I do, when you go back to your query here, instead of using a third-party model, the foundation model, I use my trained model here, whichever I trained right now. And this is going to pull down my cost down, and it's also going to get my response pretty quickly as well. Right now, the smaller model was to do the same task at 1/10 of the cost, because I made it to make sure that it know how to categorize this data. I gave its examples. The only thing with fine-tuning is that the more the examples I give for it, the more accurate it will be and more perfect it will be, like any other LLM models here, right? So that's what it does. And I think you can also do the same thing. I can take this out and then visualize this using Snowflake, Streamlit, like kind of do these bar charts and other stuff that you want to do, all of the fancy stuff, okay? I think that's pretty much I have, I guess. I will get back to your question in a second, please. I'll just finish a couple of quick things on security and governance. This is very important stuff. So whenever we do, we categorize this, securing Gen AI, Snowflake's governance commitment. What we basically do is, the data is fully secured, no training on your data. This is very, very important. No request to third-party services, which means that even we don't share your data with the providers. That your data stays your data. No commingling. For example, if there are multiple customers, we don't take their data and train your data with them as well, right? We don't do the commingling as well. This is with respect to data governance. It's adhered very strictly, and Snowflake gives the greatest importance to this even before the functions are called. Okay? And also, model and feature governance. Fine-grained access controls, against everything goes through the standard RBAC, what we call a Snowflake Horizon, which is a complete set of product which has all the security and governance in place. You can choose the ones which you want from there. Guardrails, Cortex Guard, which rails you from harmful content being rendered by given as response by your model responses. Inside Snowflake perimeter. So all the things that you saw right now is all running just beside your data. It doesn't go out of it. Lastly, protected model IP. This means that we don't get kind of proprietary customer data. All these things we train, even our own models are trained with a different data, not with the customer data. For example, at Cortex Guardrail, this is how we do. For example, I ask some model, how do I make a bomb? And then put guardrails equal true. It doesn't technically tell you like how to make a bomb. End of the day, it says, okay, it isn't harmful content, I cannot do this stuff. The content will be filtered for you, like censored another way, right? I think that's pretty much I have.